ChatGPT always sounds so confident, but have you ever thought, when asked about specific things like how many people attended my parents' wedding, do you think it'll be able to give a right answer? Most of the times, its answers aren't pulled from real sources. It's generated from patterns in training data. But what if the LLM had access to a knowledge base or a database or a log that had information about everybody who attended that wedding? Now, your LLM can generate a very good answer. This is called Retrieval-Augmented Generation, or RAG in short. This is what makes LLMs like ChatGPT trustable when asked about very specific things. Okay, so imagine this. You're in a class. Your teacher says you have a surprise test today. Now, if it was a closed book test, you'd probably answer purely from memory, in the sense from what you've learned, that's your training. Some answers can just be guesses, so it's not always correct. But if it was an open book test, you can now look things up. You have a knowledge base, that's your textbook. RAG is like your open book test. It's pretty simple, right? Now, let's plug in our classroom analogy into the real system. There are 5 steps in this process. You see, in the open textbook test, step 1 would be the teacher asks a question. In the real system, that's the user submitting a prompt. Now, the student, instead of guessing from memory, he or she opens the textbook. This is the retrieval model querying the knowledge base. In step 3, the most relevant notes from the textbook comes back. In step 4, the teacher's question combines with these notes made by the student that creates what we call an augmented prompt. And step 5, the student answers. That is the LLM that generates a response and sends it back to the user. Now that we have a flow of how a RAG system works, let's look at the involved participants a bit more in detail. Everything starts with the knowledge base. It's like a massive external data store filled with PDFs, websites, guides, documents, and audio, all unstructured. To make it searchable, every piece of data gets converted into something called embeddings. Embeddings are numbers that place content into multi-dimensional vector spaces in this data store. In simpler words, related ideas land close together and different ideas drift apart. Documents are chunked. They are broken into small pieces so that they fit into the LLM's context window. Now, why is this a window? It's because the size of the chunk that is being fed in as context matters. If there's too much context, then the results get vague. If there's too less, then the meaning breaks apart. Once the knowledge base is ready, the real journey begins. Your question enters the system and becomes an embedding, just another dot on the map. The retriever then gets to work. It scans the entire vector space, not looking for matching words, but looking for meaning. It measures distance between dots and finds pieces of knowledge closest to your question. Those nearby points are pulled out and routed back into the system. Now, the integration layer comes in. This is where everything comes together. Your original question is paired with the retrieved information from the knowledge base, and then it is combined into a single enhanced input called an augmented prompt. So here, there are some prompt engineering rules that organize the data so that the LLM receives clear instructions. With the augmented prompt ready, the generation begins. So initially there was a question and there was a knowledge base. So LLM took this question and retrieved all information that it could get from the knowledge base, and now it's not generating an answer from nowhere. Like it has a source now to generate an answer. So it's factual. It's crazy to think how many possibilities open up when you personalize AI. RAG is just one method. You can fine-tune AI models, which we'll take a look at in the next video.